Hi, welcome to Group 8's project. We're going to be talking about geometric optics, namely two things, reflection and refraction. Those two R words basically just describe how light moves. Reflection is how light bounces, and refraction is how light bends. So we're going to start with reflection because that's kind of the easiest one to do. So, reflection is based around the law of reflection, which states that the angle of which light comes in is equal to the angle of which light goes out. So, in a little diagram we have here, we have our light source in this beautifully drawn flashlight that's going to hit this mirror that is laid flat. It's going to hit it, and then at this angle it bounces, or at this point it bounces. We draw like an imaginary line there, which is perpendicular. And then it bounces up to whatever target you have, whatever receiver, whether it be your eyeball or this weird bucket drawing. So basically, it hits here, and then this angle is formed, and bounces back, and this angle is formed. And these two angles and these two angles are equal to each other. Now that may be a little hard to understand because we don't necessarily see light that easily bounce. But think about what does bounce, like a ball. Replace this flashlight with a ball, and if you were to throw a ball at the ground, and it were to bounce up, you've seen that a million times. You've thrown a ball, it hits one angle, bounces up at the same angle. Light behaves in the same way. So let's do just a quick problem. So we know this mirror is flat. So let's just say we broke out the protractor. We measured that this angle relative to this imaginary line and that at the perpendicular, and this flat ground is, let's say this was 20 degrees when we measured it. So just a quick math to find out what this angle means. So we know this full thing is 90. 90 degrees minus 20 degrees equals 70 degrees. So therefore, since we know these two things, being 20 degrees and 70 degrees, we know that these two angles are both 70 degrees and 20 degrees. That's the law of reflection.
You can start.
All right. So now we're moving on to refraction, which, as we found out, was how light bends, sort of. And one thing that refracts light is your eyeballs, what you're using to watch this video right now. So light goes in through your eye, first through a little small layer called the cornea, and then through aqueous humor and a bunch of other anatomy gunk that we won't get into. So we can measure how much light is bent by the cornea, for example, through this formula called the index of refraction formula, which states that the index of refraction, in this case n, is equal to the speed of light divided by the speed of which light travels through its medium. In our example, it's going to be the cornea. Now, it's a known fact, you can just look up in an index, that the index of refraction of the cornea is about 1.376. And the cool thing about the index of refraction is that there are no units. That's just a number as is. And we know the speed of light is 3 times 10 to the 8th, which is just 3 with 8 zeros next to it. Really fast, basically. So as we see with this beautifully drawn example of your eye, this is the cornea, comes through, light would come in. So we can actually measure how fast light would go through when it first hits your eye. So it's going 3 times 10 to the 8th meters per second, and then it hits your eye, we're going to see how fast that changes. Just very quickly like this. So we know n is equal to 1.376, and that the speed of light is 3.0 times 10 to the 8th divided by v. Just some quick algebra, we just switch these two around, have v is equal to 3 times 10 to the 8th over 1.376, and we get the speed at which light travels through your eye, the cornea, when it first hits it, to be about 2.18 times 10 to the 8th, and that's meters per second. That's the law of refraction.